metric space. So today I shall start metric space. Happy New Year to all, and wish you that the this long vacation has was very nice and peaceful, and you have learned a lot, but you could not see each other. There is the same problem. I had been in home for last 9 months, and I could not get outside of my house, or rather you can say people did not allow me to come to go out. বাড়ির লোকজন কেউ আমাকে বাইরে বেরোতে দেয়নি। যাই হোক, আমরা এখন ক্লাসটা শুরু করছি। এই metric space, metric space, metric space. Acha. Mathematically let A is a non-empty set. A is a non-empty set. Now A may be any set having mathematical objects as its elements. Okay, A may be our most important set is R, that is real number set. So we shall denote it as real number set of real numbers. Okay, so A may be R also. Now there it is a set, it is a non-empty, that means there must have some, it is not, A is never equal to phi. Okay, phi is the null set. Now we define a metric here. We define a function that is called metric if it has some properties. Okay, so let us, in some book you will get it as row, or in some book you will get it as D. Okay, so I shall use row or D, whatever it is there. Okay, let us use row. So row is a mapping from where to where. Now from A cross A to always real number set. This is very important. So this is a mapping. So and there is two elements, one element from A, another element from the same set A. Okay, so let X belongs to A and Y belongs to A. So we shall write it row of X, Y, and this is called Cartesian product, you know it, and this will represent some number in the real number set. Okay, so this is the function value. Now we can define this function in many ways. We know that x plus y is a function, x minus y is also a function of x, y, but these functions, not only functions, it must have basic properties 3, but you can make it as 4. I shall tell you the properties first. What the properties that row xy must have? Number 1, row xy must be always greater than 0. Okay, must be always greater than 0. That is called non-negativity property. Number 2 is, if row xy, you can put it as equal to 0, is equal to 0, this double implies, that means both side implications, x and y are equal. Okay. Number 3, x and y are equal, that means x is equal to y. Number 3 is rho xy is equal to rho of yx. That means if you change the role of x by y and y by x, the value, this r, will not change. Okay. So that means this is called symmetricity. Symmetricity property. Okay. And number 4, this is the most important, that is, suppose, and this is true for all xy belongs to A, and this is true for all x. Now 4, let x, y, z belongs to A. Okay. Then for any x, y, z belongs to A, then rho of xz will be less than equal to rho of xy plus rho of yz. This is called triangle property. Triangle property. Triangle property. Okay. Now you see, if we consider this one, and this one, then easily it follows this one. Okay. So these 3 are independent, we can call it axioms, and this one is not independent axioms, it can be deduced from these 3. Okay. So but the rho must follow these properties, and if it does, then A and rho, that means this pair, is known as a metric space. Metric space. Okay. Now rho is called the metric function of the space valid for A only. Okay. It doesn't mean that this is true for all. Now A may be any set. We'll come to the point. A may be any set. Any set having a function rho having these 4 properties, or basically 3 properties, these 3 properties is called as a metric space. Now this is a conceptual building. Okay. Now we have to see which sets or which metric sets with this row or with it has row. It has, now see, we didn't specify any form of row xy. Okay. So after deducing or after getting some form of xy, that form means some mathematical form involving x and y as variables, we will get some form, say as for example x square plus y square. So rho xy may be x square plus y square. In this is the called form of the function rho xy. Okay. Now if this form satisfies all these properties for the elements of the set A, then we can call it A and rho is a metric space. So we shall go on proving this. Okay. I am going to the next page. We are having one distinct, let us represent that our for x is equal to x y belongs to R. So let A is equal to our R. Then and rho xy, there is a function. So rho xy is like this, that is R cross R to R. It may so happen. So rho xy is like say that is equal to 1 if x not equal to y, and 0 if x equals to y. Now you see all the 4 properties is satisfied by this is 0 and 1, so these are greater than or equal to 0 if x is equal to y, so it is given in the row xy, definition of row xy. And say triangle property xz, so xy is 1 and x plus y and yz, this is also 1 if y equals to z, so it is 2, and so xz is less than 2 or it is equal to 0. So all these 4 or 3 properties holds for this matrix, okay, if xy belongs to R. This is known as discrete metric. Discrete metric. This is the most trivial metric, okay. So this is a discrete metric. So for the set A, is equal to R, okay. Now if any A, say A is not equal to R, but we are getting this one for A is not equal to R, but we are getting this relationship for A, then A is also a trivial, this row for A is a trivial metric, okay, so this is called trivial metric, okay. Now usual metric, there is one word you will encounter here, usual metric, usual metric, okay. What is called usual metric? Okay, you have heard about absolute value of a number. Now here absolute value is true for always, say for all x, y and so on belongs to R. So A is equal to R here. So our row is a function R cross R to R, okay. Now what is the definition of this? Definition of modulus x or absolute value of x is equal to x if x is greater than 0 and is equal to minus x if x is less than 0, and this is also greater than equal to 0, it is 0. So mod x is a mod x, okay. If mod x is there, and mod x can be written as mod x is equal to maximum of x and minus x. This can also be written as, or mod x can be written as plus square root of x square, okay. So for any two real numbers, we can define, again someone has entered, okay, let me see, hide down, Muhammad Abraj Ali, you are too late, okay. I shall not allow you to enter if it is happened next day, okay. Next, now let us define that for this R. Now our set is R. Now so define that row of xy is equal to modulus x minus y, okay. We have defined this modulus x minus y. So we have to check that all the 4 properties holds there, okay. How? Now see, from it is very easy to see, if it is 0, if this is 0, this implies x is equal to y. So this is the necessary and sufficient condition. If vanishing of this one is nothing but equality of x and y, this holds. So first property holds and second property always holds because this is, so first and second property holds. Now you can see this is also, this can be written as y minus x, so symmetric property also holds. So first 1, 2 and 3 holds, it can be seen easily. What is about fourth property? Fourth property is the triangle inequality. Now that also you can show. How? Say modulus x minus z, and that can be written as modulus x minus y plus y minus z. Now this is less than equal to modulus x minus y plus modulus y minus z, and this is nothing but row of xy and row of yz. So row of xz is less than equal to row of xy and row of yz. So this is proved. So this metric is known as usual metric for R. Usual metric for R. Okay, usual metric. So whenever there is the phrase usual metric for R, you have to think that metric is like this. Okay, metric is like this. So next page. now that there are so many spaces, okay, let us see what is the usual metric for if A is equal to complex space. Complex C. C means set of all complex numbers. Okay, now you should know the complex algebra. Okay, we need only the complex conjugate. Now say, so let us define the row in this manner. Row of say z1 z2. Z is a complex set, so all the number z are belongs to the C, and this row is nothing but C cross C, but it will map to R. So the action of row on z1 and z2 should be a real number. So let us define it as like this, that is z. So z can be written as z1 as x1 y1, that is x1 plus iy1, and z2 is equal to x2 y2, that is x2 plus iy2. Okay, so here you can write it as x1 minus x2 whole square plus y1 minus y2 whole square. And you see first 1, 2, 3 are very easy to prove, so I leave it. Okay, first one, if this is equal to 0, suppose 0, then what is there? So individually these points are 0, these two summation are 0. That means x1 is equal to x2 and y1 is equal to y2. That means these 2 points coincides. If these are greater than 0, then they are different, and just reverse it, z2 z1. So what will happen? Nothing will happen here. So first, second and third can be proved very easily, but the fourth one you can prove it by just find to prove the fourth, that is say z dash or say z dash plus z double dash. Okay, now modulus. Okay, you find out the modulus. This relationship you should know from your knowledge, z dash plus z double dash into z dash plus z double dash, its complex conjugate, from this relationship. Okay, now if you from this relationship, if you go on carrying, finally you will find, if you go on carrying out the calculations, you will find, and you know it, that's why I am not doing it. If you are in first year students, then I could have done it, but you are now second year first sem, so you should have known it how this is possible. Okay, modulus z is equal to z into z bar. Z bar is the complex conjugate of z. Okay, that is a very known theorem in complex algebra, and you will get it as z dash modulus plus z dash double dash modulus whole square. Okay, now you use this result, you will get the result at once. Okay, So this C with this C and with this metric A, that is C and row, is a metric space. Okay. Now this is about one dimensional real number metric space and one dimensional complex metric space. Okay. What about say two dimensional space? Okay, let us take two dimensional space is known as real number space is R2. That means every space, so A is equal to R2. Okay, R2 means every member of this R2 can be represented in this form x y, where x belongs to R and y also belongs to R2. So R2, that is R2 is nothing but it can be written as R cross R. So Cartesian product of two real number space. Okay. So x is written in a two number system, x1 y1, and y is written as x2 y2. You can use x2 x1, well, let us use this in this form. x1 x2 and y1 y2. Okay. Now if this happens, we have to first choose row of xy. Row of xy. Now choose it as the distance, that is the two dimensional distance. So this is a point and this is a point. So it has coordinates x1 x2, it has coordinates y1 y2, and there is a point here, so you can draw this one. So this is nothing but this distance is direct distance, so you can calculate this one, you can calculate this one, and this is nothing but row of xy, that is equal to root over x1 minus y1 whole square plus x2 minus y2 whole square. Yes. So this is our, and with a positive sign. Okay. So this is our metric, and you will see that this can be proved very easily. Okay. Positivity, symmetricity, and equal to 0 can be easily proved. Okay. And this one you have to take. I am not giving you this any assignment, okay, but you have to prove it for the fourth one for the triangle inequality. Okay, you have to prove it. Just I don't need it now, but you can do it. Okay, you can do it. You can do it yourself. I am not doing it. Okay, you can get it in any book very easy. That's why I am not doing it. Okay, so take any point x, y, and u, and u is nothing but u1 u2. Then find out x1 u1 whole square plus x2 u2 whole square square root should be less than equal to say yu yu and xu. Xu is there, so another point is there, xyz is there, so xz will be equal to xz and yz. So here xu and yu. So you have to find it out. Okay, do it. You can. This is simple tricks in mathematics. You have to write down the way you have to, or if you know the, what I will tell, if you know the properties of the square roots, then you can do it easily. Okay, properties of the square roots, you can do it easily. Okay, I leave it, but you will show me because different people can prove it differently, but I will credit one, the shortest one, but don't see the book, don't see the book, do it yourself. You can do it in many ways. Okay, now this is called 4. That means you have to prove, say u is another one, u is another one point, that is let u1 comma u2. So rho of xu is less than equal to rho of xy plus rho of yu. Okay, so rho of xy you know, rho of yu you know. You have to show that rho of xu, that means this, putting y in putting u1 and u2 in place of y, you have to show this. Okay, so next page. Next is rectangular metric. Now see what is called rectangular metric. Rectangular metric is something different. Okay, so rectangular metric. Rectangular metric. Now rectangular metric, here metric space is like this. So this is a 2-dimensional. Here also R is 2-dimensional. That means A is equal to R2. That means equals to R cross R. So one is in this way, another is in this way, and x1 x2 is this point, and say y1 y2 is this point. So you can draw perpendicular here, you can draw perpendicular here, from here to here. Okay, this point is C. So A, B and C. Now see, rho xy, we defined it. Rho xy is defined as, modulus x1 minus y1 plus modulus x2, x1 minus x2, it should be x2 minus y2. In this way it is defined. Okay, but the point is, A point is x1 x2 and y point is y1 y2. Okay, so difference is, this is y1, this is how much, this is y1 and this is x1. Okay, so actually we are x1 minus y1. So actually this, the difference of this, so this part, and x2 minus y2. So what is x2? x2 is this one and y2 is this one. Okay, so here this difference. Okay, so this difference plus this difference. So metric is constructed in this way. Okay, so difference along x-axis and difference along y-axis. This is called the rectangular metric on R2. Now this also satisfies the metric space properties. Okay, that means this is, with this metric, A and rho is a metric space, Now you prepared this one. Okay, you prepared this one. Do you have any books, answers? Do you have?
Yes, sir.
Which book? Jaydev Pal or Jaydev Sengupta?
Sir, Joydev Sengupta.
Okay, you will get it there. If you, all of you have this Jaydev Sengupta book, then don't do it because it is done there. Okay, but if you don't have, then you need not have to, don't have, then you can do it as an exercise. It is there. Okay, and this is not that much important, but the idea will be cleared. Okay, now extend, I am just telling you that you can extend to 3 dimension, you can extend to 4 dimension. Okay, only one another term will there in 3 dimension, in 4 dimension there will be 4 term, but rectangular metric, the difference must be understood. Okay, now there is another metric you can define on this set, that rho of xy is equal to maximum of max of x1 modulus x1 minus y1 and x2 minus y2. Okay, so max. You will also get in this book these examples. Okay, how to prove it. Now see, in your syllabus this proof is very important and it is long, also lengthy. You have to answer it in full form, so prepare this very nicely. Okay, these two. Then generalizing it, that is, let A is equal to Rn, that is n dimensional real number field. That means every member Ax has been represented in this form x1 x2 dot 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 xn. Okay, and y is equal to like this y1 y2 dot 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 yn. Now here you can generalize, that is how many? So rho of xy is equal to max of modulus x1 minus y1 x2 minus y2 x2 minus y2 modulus x2 minus y2 and so on, comma modulus xn minus yn. Okay, max of this, that also forms a metric space. Okay, but see, you have to prove it. In proving this one, this requires special attention. Special attention. Remember this part. You can write it max of in this shorter form, max of modulus xi minus yi. Okay, I is equal to 1 to n. You can write it in this form. Now these two examples are very important and you have to use the maximum, that is the formula and knowledge of this modulus mathematics. Okay, now this one is the, these three examples are very instructive. Okay, okay, now what about this matrix? Now before proceeding further, because there are three inequalities, that is Cauchy-Schwarz inequality, then Minkowski inequality and Holder inequality. These three were, before proceeding to that, I want to say you something, that metric space has got some properties like you have seen that in doing calculus you have used this fact. Okay, say xn, using this fact, say xn tends to x. We seldom use this one in series, in everywhere, that which means that xn is a series of numbers and these numbers converges to x. Okay, and in that way we proved it that limit n tends to infinity modulus xn minus x tends to 0. Okay, that means, and we told it that this means that modulus xn minus x is less than equal to say delta. That delta can be maybe however small. Okay, so that means this xn is approaching x without any bindings. Now the difference between xn and x is, so you see this is nothing but the usual metric in real number space. Okay, then there is another one in studying limit, that if this happens, then some function xn tends to say fx. Okay, that means the series of functions is been converging to fx. Okay, so again this means that if nx minus fx is less than equal to epsilon as n tends to infinity, then we say that this happens. If this happens, then this happens, or that means delta epsilon definition of limit of a function has been explained. But this expression is nothing but rho xy, is nothing but rho x, and this is y. So this is x and this is y. In the function space, this is a point and this is a point. So these are C points representing the rho xy. Here in the real number space, point representing xn and y, they are rho xy. So whatever we have taught in real analysis, everything can be repeated here, can be repeated, but with a broader outlook with rho xy. So this is one point you have to remember, that we have generalized all these forms, okay, in rho xy. Okay, and this rho xy plays the role of these functions here. This is one of the very important observation or generalization of real analysis to the metric space. Now metric space is beginning of the studies of the topology, beginning of the study of the topology. Okay, all metric space are topological space, but not vice versa. That is, all topological space are not metric space, but all metric spaces are topological space. Now topology studies with the form of an object. Okay, so metric space also the form of this form. Actually this form is nothing but a geometrical form. Why it is not geometrical form? Because this is nothing but the distance between xn and x. So xn minus x means that distance is gradually decreasing to, and at the converging point it becomes 0. Here also distance between fnx and fx is decreasing, and epsilon may be small as we please. So actually this tends to 0. So distance is a metric property, that means it is a geometrical property. You have learned from your Euclidean geometry that distance between 2 points may increase, it never positive, it is never positive. So distance between 2 points determines the geometry. So nothing, we are studying the algebra with the help of algebra, the geometry of the problem itself. Okay, so studying geometry in terms of algebra is known as topology. Okay, it knows as topology, and metric space is the beginning of the topology. Okay, so with this today I like to give you some assignment. Okay, assignment number 1. Assignment number 1. Okay, you write down the assignments I shall give you from a different book. Okay, you will not get it in this book. Okay, so assignment 1, you may get it, but I am giving you, do it, you try to do it. পড়াচ্ছি। Let me see it. Okay, first assignment 1. Now you send it assignment in this form, in this format. Write your roll number first, roll number, okay, roll number. So say your roll number, I don't know, I am giving you this roll number, complete roll number, okay. Then your first name, then first name, then write down 3, okay, write down 3, that means you are third sem students, and then write down assignment 1, okay, assignment 1. Now say assignment 1 first page, so 1 1, second page 1 2, third page 1 3, or you can convert it and then dot PDF, okay, PDF, and then send it to me, to my WhatsApp number, okay, assignment. And assignment must be sent within the due dates. Due dates will be like positive, say 3 days or 7 days as per the number of assignments, okay. So this is roll number. As for example, I am give you, say you are students from 19, so 19, roll number is 19, then Mtmh, say Mtmh, then your roll number is 375, then your first name is say Shubimal, then 3 dash 3, assignment 1, say page number 1, so dot PDF. So this will be the name of your paper or of your assignment, and then second one is same like this, save it in PDF format and then send it to my WhatsApp number 8617805590, okay. You got it? Have you understood all? This, in this format you send it, that will be easier for me to store in a format in my computer, okay. Now the first assignment, let this CAB, I am just explaining, you see it, CAB, space of all continuous functions over A and B. It can be written as space of all continuous functions on the set A, on the interval AB, closed interval, okay. So let us denote it, and this is our A, so A is equal to C AB, and sorry AB, and row of xy, so x is a function also, it belongs to this set, and y is also a function to belongs to this set, okay. Row xy is equal to maximum or supremum of modulus xt minus yt, okay, for t lying between A and B. With this matrix you have to prove that C and row is a metric space. This is very easy to do, but I want to see, don't copy the book, it is given in any book, but I want you, everyone should write it in your own language. Have you got it? Write it in your own language. Don't write or copy any book or any notes. You have to write it in yourself. And almost all books I am having, and I understand the writing, what is written in copying from the book and what is not, okay. Have you got it? I think you have got it. So this is your, now what you have to do, you have to send all your, now you start sending all your roll number, name in the chat box. Okay, you send all your roll number and name in the chat box. All you are present, roll number and name, you start sending in this box. Yes, okay. Navin Das, Bishwajit Vishwas, Sneha Vishwas, Arbaj, don't make so many so late. Yes, from the next class.
Yes, sir.
Okay. Sneha, don't make late. Parthona is in right time, but the other people, how many people? 14. So only 4 have. Only 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 people has left the meeting. Okay, understood, right? And these 5 people will get the attendance marks, because everything is getting, you know. Okay, then you can leave now.
হ্যালো স্যার।
Yes, what happened? Tell me.
হ্যাঁ স্যার, বলছি আমি রিপন বলছি স্যার। তো আমিও রোল নাম্বারটা এখানে দিয়ে দিচ্ছি।
হ্যাঁ, তোমার রোল নাম্বারটা এখানে দিয়ে দাও, ওকে দিয়ে দাও, ও সোহানের ইয়েতে পাঠিয়ে দেবে।
হ্যাঁ স্যার, ঠিক আছে।
ঠিক আছে। Now it is in G Suite, it is recording, so your presence is also recorded. When you are leaving, that is also recorded. When you are entering, that is also recorded. Remember this. This is a G Suite, not Google Meet. It is G Suite. Okay, then I am stopping recording. Okay, then you can leave now.